A vertical tree 2.5 meters tall is 13 meters away from another vertical tree 3.2 meters tall. Both of these trees are on the same plane. 1. Write an equation for the line passing through the top of these trees after choosing a coordinate system. 2. Use your equation to find approximately how far behind the smaller tree should a person of height 1.8 meters stand in order to be able to barely see the top of the taller tree. I start the question by drawing a sketch of the trees. There is a taller tree which is 3.2 meters tall, and there is a smaller tree which is 2.5 meters tall, and the distance between the trees is 13 meters. Now the top of the trees are these 2 points. I call this point A and the other point B. We are interested in the equation of the line passing through these 2 points, and that would be this line. We realize that there are no coordinate systems given. In fact, a coordinate system is something that does not exist in nature, and we choose the coordinate systems and we bring them into the problem. I can introduce my coordinate system in many different ways. I can put the center of the coordinate system here, for example, with the y-axis vertical and the x-axis horizontal. Or I can put the center of the coordinate system at the top of the smaller tree, which would be here, with the horizontal axis to be the x-axis and the vertical axis to be the y-axis. Both of these choices are as correct. I can also choose the top of the taller tree, point B, to be the center of the coordinate system, with the horizontal axis to be the x-axis and the vertical axis to be the y-axis. Or I can choose this point as the center of the coordinate system. Or I can choose the point midway between the 2 trees on the ground, this point. All of these choices are as correct. However, the algebra would become different in different choices. Some of the equations might be easier than the other ones. For example, they would have fewer terms, but they will all lead to the same physical answers. In solving this question, I am going to experiment with 2 choices. Either of these choices are correct. One of the choices that I'm going to have is this point, the base of the smaller tree. And the other choice that I'm going to have is the top of the taller tree. Let's start with the base of the smaller tree. The y-axis would be this axis, and the x-axis is this one. Once we choose the coordinate system, we can give points A and B their coordinates. Point A has the x-coordinate to be 0 because it is exactly on the y-axis, and the y-coordinate to be 2.5. Point B has its x-coordinate to be 13 and its y-coordinate to be 3.2. If I have the coordinates of 2 points of a line, I can write down the equation of the line. I will use the 2-point form of the equation of a line. That is y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. I can choose either of these to be x1, y1 or x2, y2. I'll choose these two to be x1 and y1, and the coordinates of point B to be x2 and y2. Once I plug in these values into the equation, I will have y minus 2.5 divided by x minus 0 is equal to 3.2 minus 2.5 divided by 13 minus 0. I can use a calculator to find the right hand side to be equal to approximately 0.0538. Please note that I am not really careful about the significant digits in this problem. I can cross multiply this equation to get y minus 2.5 is equal to 0.0538 times x. And if I carry minus 2.5 to the other side of this equation, I will have y is equal to 0.0538x plus 2.5. This is the equation of the line connecting the top of the two trees in the coordinate system that I chose. If I choose a different coordinate system, the equation will look different, but that is okay. Any physical quantities that we determine using this equation or the other equations would be the same, as you will see. I'm going to solve part B of this problem using this choice of the coordinate system and the equation that I have found for the line. Let's look at the sketch again. If there is a person of height 1.8, he would be, let's say, somewhere around here, behind the smaller tree, trying to look at the top of the taller tree. This would be a sketch of the individual who is 1.8 meters tall. Now, let's show the position of the head by M. The coordinates of M are the x coordinate would be the distance between the person and the tree. I will call this D. So D is just a positive number showing the distance. But because the person is on the negative side of the x-axis, the coordinate would be minus D. Now D is a positive number. And then the y-coordinate, it's above the x-axis, it would be 1.8. If point M is going to be on the line connecting A and B, if M is on the line connecting A and B, then the coordinates of M must satisfy the equation of the line. The y-coordinate of point M is 1.8. We put that in the equation. That must equal 0.0538 times the x-coordinate, which is minus D plus 2.5. There is one equation here which has one unknown, which is D. We try to solve this equation for D. Let's move the 2.5 to the left hand side of the equation. We get 1.8 minus 2.5 is equal to, and we multiply the minus sign into 0.0538, and then we have D. Now we divide both sides by minus 0.0538 to isolate D, and we will have 1.8 minus 2.5 divided by minus 0.0538. That becomes D. Of course, this is approximate because I rounded at some point to get this number, 0.0538. If we use our calculators, we see that D is approximately equal to 13 meters. Therefore, if a person of height 1.8 wants to see the top of the two trees aligned with his point of view, then he would have to stay 13 meters behind the smaller tree. Let's now solve this question by a different choice of the coordinate system. Let's sketch the trees one more time. We have a taller tree which is 3.2 meters tall, and another tree which is 2.5 meters high. The distance between the two trees is 13 meters, and I'm going to choose the top of the taller tree as the center of the coordinate system. Then the x-axis would be this line, and the y-axis would be this line. The top of the two trees are this point and this point. As before, I call the top of the smaller tree by A and the top of the taller tree by B. Now I can give the coordinates for both points A and B. Point B has the coordinates 0 and 0. Point A has the coordinates minus 13 and this distance, which is below the x-axis. The distance is 3.2 minus 2.5, and because it's below the x-axis, it would be negative. So 3.2 minus 2.5 is 0.7, but because this point is below the x-axis, this is the x-axis, is below the x-axis, that would be minus 0.7. This is the coordinate, y coordinate of point A. Now I can write down the equation of the line passing through the points A and B. I will choose this time x1 and y1 to be 0 and 0, and x2 and y2 to be minus 13 and minus 0.7. The equation would be y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. I can use a calculator and find the right hand side. I would have y over x on the left hand side is equal to 0.0538, and if I cross multiply both sides of this equation, I will have y is equal to 0.0538 times x. This is the equation of the line passing through the top of the two trees in the new coordinate system. As you can see, this equation looks simpler than the equation we found before, because the other equation had another term appearing in the equation, 2.5. Now let's go back and continue the rest of the problem. Part B of the problem is solved this way. The individual is standing behind the smaller tree in such a way that the head of the individual and points A and B are all on the straight line passing through A and B. Now we need to find the coordinates of the head of the individual. Let's say the individual is d meters away from the smaller tree. D is a positive number, it's just the distance of the individual from the tree. if the individual was on the right side of the tree, we would still use D. But the coordinate of point M, which is the head of the individual, are found this way. The x of the point M, let's say this is x, as we can see, is equal to 13 plus D, but with a negative sign. So the coordinates of M are minus 13 plus D, that would be the x coordinate, and the y coordinate is found this way. The individual is 1.8 meters tall, and this total distance is 3.2 meters, which is the height of the taller tree. The difference with a negative number would be the y coordinate. The difference is this, which is equal to 1.4, and because it is below the x-axis, point M is below the x-axis, we need to use minus 1.4 for the y coordinate. If point M is going to be on the straight line that we found, we should have that the y of point M is equal to 0.0538 times the x of point M, which is minus 13 plus D. We can simplify the right hand side by multiplying the minus sign into 0.0538 to get this coefficient, and then in the bracket we will have 13 plus D. We divide both sides by this coefficient, we will have minus 1.4 divided by minus 0.0538, and on the right hand side 13 plus D. We move the 13 to the left hand side, we will have minus 1.4 divided by minus 0.0538 minus 13 is equal to D. If we use our calculators, we see that D is approximately equal to 13 meters. And this answer agrees with the answer that we found by the different choice of coordinates that we made in the previous solution.